course, they are talking about the annual path of the sun and how out south their summer is our winter and vice versa based on the proximity to the sun. So the analemma is a diagram that shows the position of the sun in the sky over the course of a year as seen from a fixed location on Earth. The diagram is shaped like a figure eight. The shape of the analemma is allegedly determined by Earth's tilt, spin, and orbit. And lastly, we have the Doppler effect. The change in the frequency of light from stars as Earth moves towards or away from them allegedly supports the idea of Earth's orbital motion. So let's break these down. So, retrograde motion, again, the apparent retrograde is the apparent motion of a planet in a direction opposite to that of other bodies within its system. We have a visualization there for you that's time lapse, I believe, of Mars throughout the year. And as observed from a particular vantage point, the term retrograde is from the Latin word retrogradus, backward step, meaning backwards and step. Retrograde is most commonly an adjective used to describe the path of a planet as it travels through the night sky with respect to the zodiac, stars, and other bodies of the celestial canopy. In this context, the term refers to planets as they appear from Earth, stopping briefly and reversing direction at certain times, though in reality, of course, we now understand that they perpetually orbit in the same uniform direction. Now, this is, of course, the heliocentric position. So they're claiming that because the Earth orbits around the sun, on occasions, it makes the planets, the interior planets, for example, appear to go backwards. And that is called retrograde. And that is proof that everything is orbiting around the sun and it's just an illusion. So here is a depiction of it for you. And you'll see they obviously have the Earth moving around the sun with Mars moving around the sun. And as it crosses in front of the Earth and between the sun and Earth, it appears to go backwards. Now, this is not exclusive evidence that the Earth is moving at all, of course, because as we discussed last week, you can simply just put the marker on the Earth. And so this here is a sped up depiction of a neo-Tychonic system, which is a certain geocentric model. And this has everything moving in relation to the sun as the whole system moves in relation to the Earth at the center. So people, of course, make the assumption that the Earth is what we see in the sky and that it's all moving around like the lights in the sky. And this is just a baseless assumption. But you will see here in the neo-Tychonic system, we have these motions. And for one, these motions, if actually fit perfectly within a torus field. So if there was actually a magnetic field that was causing the motion of these bodies, it actually makes sense physically as an actual motion that they would make these little swirls, because that is the torus field geometry within a magnetic field. So it would just be seeking equilibrium within that. That's a bit further down the road if we were to ever really speculate alternative positions. But nevertheless, as you can see with this depiction here, this is the Earth in the center and everything moving around it. Okay, it's called a neo-Tychonic system. Okay. Let's move to the next slide here. Okay, here, think about this here, right? So this has everything moving around the sun. Now, once we move over here, if you were to have everything moving around the Earth, but then the quote-unquote planets moving around the Earth with the sun, right? It's all moving in relation to the Earth, then you would have the exact same cause for retrograde as you would in the geocentric model. Hopefully this makes sense in the heliocentric model. It's that it apparently goes backwards. It's not actually going backwards. You can see it just keeps going in the same direction around the sun. But as it crosses in between the sun and the Earth, it's going to look like it's going backwards from the vantage point of the Earth because it's in relation to the background. Now, like I said, there are many different options. This is not the only alternative, is the neo-Tychonic system. In fact, the actual planets could just occasionally slow down in relation to the background stars, and they would, of course, look like they're going backwards because you're measuring against the background stars. In addition, they fit right within a magnetic field geometry. So if it was actually magnetism causing the motion in the sky, we could expect that to be an actual observation of what the stars are doing. But even if it wasn't, the exact same claim of heliocentrism is exactly what would explain it from a neotychonic geocentric model. So really simply, you're going to look out and it's going to look like the planet's going backwards. It's not. It's just that it's in relation to you. It looks that way, which is a pretty simple concept. So when you Google it or when you talk to someone that claims that
Okay, that may explain uh, retrograde motion, but how about phases and transits? Mercury, the innermost planet, not Mars, and Venus will show phases if they are about 90 degrees away, 90 degrees to us from the sun. Only the side of the planet facing the sun will be illuminated, and it will show a half phase to the Earth. Plus, if the Mercury and Venus do pass in front of the sun, we get transits, which we do observe. We don't observe transits of Mars, Jupiter, Saturn, Uranus, Neptune, or Pluto, because they're on the other side and they don't pass in front of the sun. Plus, they don't have phases, because if they're at 90 degrees, the sun we're aligned, so we could just see the full face of the planet, not just the face, like a half face. If it was orbiting if the sun was orbiting us, and the planets were orbiting the sun, we would get transits of all the planets, such as Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. That's why we think that's why we know that the planets go around the sun. It makes everything so much simpler. Okay. Now Witsit, go back and learn some more astronomy, and have a good day. Bye.